Okay, this is for section 1.5, and we're just going to get accustomed to using limit notation to designate vertical asymptotes. Because the formal definition of a vertical asymptote is when you look on either side of it, and as a function approaches a c value from the left or the right, the limit goes to positive infinity or negative infinity, or both sides go to positive infinity, or they go opposite ways. And then this is called a vertical asymptote. It's when on either side of one location a graph goes to positive infinity or negative infinity. And so it's really an explanation written with limits. In algebra and pre-calculus, we took the shortcut and we just factored and eliminated the positions where there were common factors. But now we're just going to write it with vertical asymptote, or vertical asymptotes with limit notation. Okay, so here's the formal definition. If f of x approaches infinity or negative infinity as x approaches c from the right or the left, then the line x equals c is called a vertical asymptote with the graph. And we'll practice a little bit more on the block day about how this actually fits into our notation and our terminology. Okay, so determine the function has any vertical asymptote. So if I have this expression, it's a rational function. And you know with rational functions, we must factor first, see if they have any common factors. They have a common factor at x plus 2 and x plus 2. So we know that at x equals 2, this graph will have a hole. We can look at that information also, see how that fits in. So we notice that the denominator is x minus 3, and at x minus 3, if x is 3, it makes the denominator equal 0, which we know we can't have. It makes the whole rational function undefined. So let's examine the limits going to 3. So again, if you're looking from the left and the right, you're going to need to sketch a graph. And this particular graph, if you remember from pre-calculus, I know I have a vertical asymptote at positive 3. I have a horizontal asymptote at y equals 1 because the degrees are the same in numerator and denominator. I have a y-intercept at positive 2/3. And I have an x-intercept at 2. All right, so we know we can do a lot more things to determine how this graph is designated. In other words, we can get a sign chart and table of values. But just going off that information, it should take this shape. All right, so as x approaches 3, coming from the left side of 3, it goes to negative infinity. And as x approaches 3, coming from the right side, it goes to positive infinity. Because the limit from the left is negative infinity and the right is positive infinity, there is a vertical asymptote at x equals 3. All right, so in calculus, if you want to state a vertical asymptote, you would include limit notation. Limit as x approaches 3 of f of x from the left is negative infinity. Limit as x approaches 3 from the right of f of x equals positive infinity. Therefore, x equals 3 is a vertical asymptote. All right, so in class tomorrow, we'll discuss the difference in the homework problems. You're mainly just going to be looking for where there's discontinuity, either with an asymptote or a hole, and looking at vertical asymptotes using limit notation. And this section for homework is going to be kind of like